To this lecture. In this lecture, we are going to talk about Amazon Simple Queue Service, which is a fully managed message queuing service which enables you to decouple and scale microservices, distributed systems, and serverless applications. SQS also eliminates the complexity and overhead associated with managing and operating message-oriented middleware and empowers developers to focus on differentiating work. Using SQS, a developer can send, store, and receive messages between software components at any volume. That too without losing messages or requiring other services to be available. Getting started is very easy. You can use SDK, CLI interface in order to use this service. And SQS also offers two types of message queues. One is a standard queues which offers maximum throughput. It offers best effort ordering and at least once delivery. SQS also offers a different kind of a queue service which is called SQS FIFO, which are designed to guarantee that messages are processed exactly once in the exact order that they are sent. So now looking at both the options that we have, you can choose your use case, you can choose the service that we have. If we have to talk about SQS standard, you can use it for maybe sending message notifications to the to your phone numbers, because that will not be a binding factor that when that message gets delivered or when that message in what order that message gets sent. So that is also very good options. And in case of let's say if you are a e-commerce website and you want to place an order, and during the payment you want to make sure that the payment request goes through at least once, and so you can actually make use of SQS FIFO, because it also guarantees that exactly once it will be delivered and it will also follow the order. So I'm just giving you a very vague use case, but there are lots of use cases that we can have in order to make sure that our SQS can be utilized in a different way. We'll talk about more on the use cases, but let's get on to other aspect of SQS. So the data that we send through SQS will be pre-processed at least once. However, the order in which will be processed is not assured. As I mentioned, the SQS standard. Amazon SQS is a fully managed service with no upfront cost or fixed expense. Pay only for what you use, with a small charge for each API request and data transfer. Amazon SQS enables an unlimited number of services to read and write an unlimited number of messages at any time. So it also eliminates the administrative overhead. So if you look at the simplicity, you can look at an architecture where you do not have to worry about sending or receiving the message between the two components. You just have to worry about how to send the message and how to receive the message, but how does that message get delivered, you do not have to worry about. You just have to choose between the two options that has been enabled by SQS, either the standard form of SQS or the SQS FIFO. AWS manages all ongoing operations and underlying infrastructure needed to provide a highly available and scalable message queuing service. So there is no upfront cost, which I have already mentioned. So these are really fantastic to use, because you don't have to worry about any administration. Plus it is reliable, and it's reliable in terms of delivering messages. So using Amazon SQS to transmit any volume of data at any level of throughput without losing message or requiring other services to be available. It also lets you decouple application components so that they run and fail independently, increasing the overall fault tolerance of the system. Multiple copies of every message are stored redundantly across the multiple availability zone so that they are available whenever needed. So the best thing is that you don't lose any message unless and until it is processed once. You keep your sensitive data secured through this service. You can exchange sensitive data between applications using server-side encryption to encrypt each message body. Amazon SQS SSE integration, which is server-side integration with AWS key management, so you can use your own key using key management service. This way you can be more sure about how your data is being secure. You can also scale elastically and cost efficiently. So Amazon SQS it allows you to scale at any length with a very cost efficient manner. AWS cloud allows you to dynamically scale based on demand, so it scales elastically with your applications, so you don't have to worry about capacity planning and pre-provisioning. And the best part is there is no limit to the number of message per queues, and standard queues provide nearly unlimited throughput. So the cost is not fixed, that you have to pay certain number of dollars or certain number of rupees. You just have to worry about how you are going to use it, how it should get delivered, and the cost and elasticity and other components are variable, and you can use it as per your flexibility. So AWS SQS can be used in cases like when you want to have IoT devices connected to your to your machines which are producing logs. Maybe there are lots of scenarios where your IoT enabled machines, they are actually sending you their alarms or alerts, and you are capturing them in the form of logs in S3 bucket. So now you already know that there is a device which is sending you alarm. Now you will anyways go and do some data crunching, or you're going to do some analytics over that data, but the timing or the order is not important. So then you can use the Amazon SQS standard service, wherein you just keep on getting the alarms and you can store it in your SQS in your S3 bucket. However, let's say there is a use case where you need to make sure that the ordering is very much important. Definitely you can go for SQS FIFO, and using these two options you can be very sure that your message will get delivered at least once, and it also gets stored as well. So there you have lots of robustness which is being made available within the service itself. And being a very highly available service, you don't have to worry about its scalability, elasticity, and of course it is cost efficient because you pay as you use. So hopefully this lecture was useful, and we'll see you in the next lecture. Thank you.